All right, today's lesson is really just a hodgepodge of stuff, some of which you should be very familiar with, those of you that took pre-calculus last year. And those that have not, hopefully this will be a great base for what we're about to do. The chapter we're going to begin is called Polynomials, and it's basically becoming familiar with the graphs that are beyond just x squared. How do you graph something that's with higher powers? And what would those graphs look like, and what patterns do you see? And then what information can we draw from those graphs? In particular, we're also going to look at limits in this chapter, something that, again, you should be kind of familiar with. So let's just start with the first graph here that we see in front of us. And I'm going to ask you some questions. If I give you a graph, what kinds of things can we ask? Now, these questions are extremely popular on the CLEP exam, so be watching for patterns throughout this thing. What interval is f increasing? Keeping in mind that this pink graph you see in front of you is in fact f of x. And so it wants to know what intervals is f increasing. Then it is asking at what intervals will there be a relative maximum. Now again, that term relative we need to become familiar with, but basically over the course of this graph, there are other maximums, and if you look to the far left of this graph, you'll notice the arrows pointing up. So obviously this graph continues to go up, so there's higher points. But when it says relative, it basically means within the domain in which I'm giving you, what is the relative maximum? What is that maximum? And again, for minimum. And then how many points are points of horizontal tangency? Thinking about what that means to be a horizontal line or tangent line. Okay, so let's look at that first one. Over what interval is f increasing? So what am I looking for? I'm looking for it going up, increasing. That definition has not changed. So when I'm looking at this particular graph, I'm asking myself, okay, where is it in fact increasing? Okay, so let's do that together. If you notice, when is the graph going up? We're looking from -8 to -6. So we're going to write that interval. Now, it doesn't actually include at -8. Why? What's going on when x equals -8? It is a minimum. In fact, it's where the slope equals 0. And so those two things will come up later, but keep in mind, it wouldn't include that. So the way that we write that interval using bracket or notation, interval notation, we would use a parenthesis to say it doesn't include -8 and it doesn't include -6. It's that interval. All right, the next interval where it would be increasing, where would the next one be? 1 to 5. Again, doesn't include 1. And then we would go all the way up. If you'll notice, even though it kind of slopes at 0 there at around 3, it's still increasing. We are still progressing. Some people might break up that interval, and you could very well do that. But I'm going to go right from 1 to 5. And then lastly, we want to go from 7 to 9. All right, where is there a relative maximum? Relative maximum. So we're not looking at just where the highs and lows, just where the maximums are. So a relative maximum in terms of its space would be at x equals, where's the first one? -6. Where again? Because there are more than one. There's one again at 5 and again at 9. And what values of x will be a relative minimum? So again, now within its space, where does it dip or again have a minimum? And so we see the first one at -8, the next one at 1, and then again at 7. And you'll notice that basically when it's asking about horizontal tangency, it's really a mix of that. You have all kinds of points of horizontal tangency. Keep in mind that horizontal tangency is whenever it comes in at 0 or there's some kind of slope. It could appear like you have a loop, and so you have a horizontal tangency at the base there. It could be at the top, like there's a point of horizontal tangency where the tangent would be 0. Or it could even be something like this, where it's kind of coming in flat and then down. And again, it would have that horizontal tangency, and of course the same on the other direction. So there's 4 different ways that you can see that. So we have -8, we have -6. Where else? It appears as though there could be one around -1, possibly. It does still have a little bit of a slant there. Not sure if there's intended to be one But it's enough of a slant that I probably wouldn't use that one. I would say at 3, though, at 5, at 7, and again at 9. Hopefully you can see all those as you look through the graph. Take a minute, look at that graph, and examine that more closely if you need to. All right, let's do this. Now, from the same graph here, I would like for you to ask yourselves these questions. Find the following limits using the graph. X is approaching infinity. Now, where is infinity on this graph? Infinity, you should notice, is going to be all the way to the right. This is just a fancy way of asking you, what is the graph doing on the right? What's the last thing it's doing? In this case, it's going down. We don't know where it's going to stop. We're to assume that because there's an arrowhead on that, that's going to continue to go on till infinity. And so the way we indicate that, of course, would be that we would actually do negative infinity, indicating that it is continuing to go downward. In a similar fashion, let's look at the next question where it says the limit as x is approaching negative infinity. This is basically saying our x is negative infinity, so that would mean all the way to the left of this, and in this case we see that it's pointing upward, which indicates that it's going to infinity. All right, last couple of questions with this graph. What are the maximums and minimum values of f of x over, now this is giving you an interval, from -9 to 2. It is different than the relative max question. The relative max basically means in perspective of the graph at that spot, you know, where is the maximum? But this is saying what literally is the maximum and minimum values. Also, I want you to notice that it says values, and values basically is saying I want the y part of it. What's the highest this gets the value? So from -9 to +2, where's the highest spot? And hopefully you can easily see that it's right here at -6, but the value that it wants is 4. So the max is 4, and the minimum between that same location, it looks to be at 1, which is at -4. In the same way, though, you'll notice the question will change as it says a different interval, -9 to -7. Notice we will look still at the beginning and the end of that interval and in between. Know that as we evaluate functions, we will always have to look at the beginning and the end of the interval as well as what's going on in between it, and there will be some processes that we'll have to take there. So the maximum it gets isn't actually at -6 because -6 isn't in there, but the maximum is where it is there at -7. And just for, I guess, ease, I'm just going to say that that's about 3. And then minimum, again, it's over that interval. It looks to me that it's at -8. So that would be a minimum of 2. Okay, good. Now to shift gears a little bit in order to continue on with this limits discussion, graphically it's pretty easy just to read the graph, but what happens when they don't give you the graph or they give you this equation? I want to take a quick moment to maybe recap what we have learned in the past about limits, or what you should know about limits. And that is this. If you're doing, maybe the key point, I should say, that I want you to take from today, and we will go through each of these indeterminate forms, I'm sure, as they come up. But remember, the highest power wins. The highest power wins. So if I'm putting infinity in here and I say, okay, that's infinity cubed, minus 10 times infinity squared, plus 2 times infinity, plus 5, I don't really want you to think of it like a number. I don't even want you to put like 1,000,000 or 10,000,000 or a gajillion in there. All I want you to do is think conceptually, what does that mean? I have a very large number cubed, and then I'm going to subtract 10 times a very large number squared. Which one's going to get there faster? If this is a contest between infinity cubed and infinity squared, who's going to win? Infinity cubed would. And the same is true for plus 2 times infinity plus 5. It's like the ocean, and we're taking just a little bit out of it. That would equal infinity. If we put negative infinity into here, we have negative infinity cubed, and that, of course, means that that would equal negative infinity. Then we'd have minus negative infinity to the fourth. Well, what's negative infinity to the fourth? That would become positive infinity. But keep in mind, you have negative infinity minus infinity. This minus didn't have anything to do with that. The negative that was inside is the part that got to the fourth. So this is simply just negative infinity. It really didn't matter whether it was higher power or not because they both basically presented the same value. If I have negative infinity inside the same example that you had in number 1, the difference is that negative infinity cubed, it is the highest value, and when you cube it, it stays negative. So the answer to that would have been negative infinity. We really could care less about the rest of those values. The x squared term, the x term, or the constant, it really isn't going to affect it much. Infinity to the fourth, what would that be? Excellent. And how about negative infinity to the fourth? The truth is, it's really trying to examine the concept of negative numbers, too. You should understand the bigger one gets the sign, or when we raise it to a power, what happens to it. A negative number to an even power will become positive. So there you have it. Good. All right, now the last part, you're going to notice this in your packets tomorrow. We work on this in class. Even if you have your packets already, you can look through this. But the goal of this is not just to, connect these dots randomly, but is actually to get you used to graphing things. You're eventually going to solve for these points, believe it or not, and then make graphs out of it. Well, we've got to understand how to actually approach them. Each of these dots are going to represent the slope equaling 0. In other words, it's a point at which the slope of the tangent line is 0, or it should come in flat. Remember earlier we were discussing the ways that this could be. We could have it where we are looking at a parabola of sorts, opening upward or opening downward, and you have that point of horizontal tangency on those. Or you could have it where it kind of bends like that, where it continues to go down. So we're going to use that same idea as we do these points. So if I'm starting at this first point here on the left, whether I start up or I start down, it really doesn't make a difference. You can pick your favorite. So let's just say I'm going to start down, and I'm going to come in at that point at 0. And then as I kind of move, try and emphasize the slowness that it comes in at. It's going to be nice and smooth. I shouldn't see any jagged edges. And here, I can choose to either go down again, or I could have gone up. Either way would have been acceptable. Not everyone's is going to look exactly the same. They'll look relatively close, but the ends will vary. All right, let's try another one. In fact, if you copy down, 5 or 6 dots on your paper, just put down some random dots, give some space in between each of them, and then allow yourself to be able to, okay, I'm going to, again, you're going to want to come in at flat. There you go. And there's another example. You'll get much practice with this tomorrow. Okay, that concludes this part of the video about polynomials. Again, it was kind of a hodgepodge of different things that we've looked at in the past, but mainly focusing on limits and just what it means to have a slope of 0. Hopefully you were able to get that instruction. Feel free to go back and look at things as you need to. And tomorrow we'll be practicing each of these items on our homework packets. Okay, I'll see you tomorrow.